In today's video, you're going to learn how to use a spectrophotometer and its results to determine the concentration of an unknown solution. Let's get started. Before using the spectrophotometer, a set of dilutions with gradually decreasing concentration should be made. Once that is done, obtain 6 cuvettes, 4 for your stock solution and other dilutions, 1 for your blank, and another for your unknown. When filling the cuvette, make sure to not add excess solution, but instead fill the cuvette up to the marked line.
Should I just get just the thing or
I guess get me too.
oh yeah. So should I zoom in after
Turn it the other way.
way?
Turn it that way. Perfect. Okay, now.
When your cuvettes look like this, you're ready for the spectrophotometer. Make sure to clean 2 sides of the cuvette with a chem wipe. You're going to start with your blank, in this case ammonia. Zero out the spectrophotometer, and once that is done, you will scan all of your solutions across all wavelengths. Why scan across all wavelengths? You scan across all wavelengths to determine which specific wavelength you will use to determine the relationship between the absorbance and concentration of the solution. By doing this, you are able to learn which wavelength is the best for determining absorbency of the solution. Another reason why you scan across all wavelengths is to determine the lambda max, or the wavelength at which the maximum fraction of light is absorbed by a solution. For this lab, our lambda max was the best wavelength for determining the relationship between absorbance and concentration.
Okay, so the first step is you're going to run you're going to blank it, and then you're going to
After scanning all of your solutions at the specific lambda max for your solutions, make sure to write down all the absorbencies of your solutions obtained from the spectrophotometer.
We can use that one big thing.
I don't know, you told me.
Always.
I remember in the video it said first.
So what's your first step before you use
I don't think we no wait, they use the scan here.
Your notebook should look something like this. To determine the concentration of your dilutions, the formula M1 times V1 equals M2 times V2 can be used. However, to determine the concentration of your unknown, the formula given by Beer-Lambert law should be used, where A equals E times B times C. A is the absorbency of your unknown, E is the molar absorptivity, or the slope obtained from your graph of concentration versus absorbency, B is your path length, which equals 1 centimeter in this lab, and C is your concentration of your unknown. Beer-Lambert law describes the linear relationship between absorbance and concentration of an absorbing species. This means the absorbance of a solution is dependent and directly related to its concentration. Concentration can be found by rearranging the equation to C equals A over E, or absorbency over molar absorptivity, since B is simply equal to 1. If the spectrophotometer had not been zeroed, the spectrophotometer would not have been calibrated correctly, and the absorbance of the solution would not have been accurate, resulting in an incorrect concentration value for the unknown solution. After using Beer-Lambert law, it was determined that the concentration of the unknown was 0.0017 moles per liter. Compiling the concentration of the unknown with its absorbency, as well as the concentrations and absorbencies of the dilutions, your notebook should look like this. Make sure to clean up your workspace and exit out of the computer program. Thanks for watching.